Hello everyone, it's June 17th. Alright, I see a difference. It's finally here. I bought a monitor. So finally cannot just live with my own laptop anymore. I need a monitor. Without a monitor, it's just things just aren't right. You don't have any motivation to do anything because I have too little real estate. Now I finally got one. Is this like the best of the best? Not definitely not. It's just something that's definitely um, a low medium tier, I think, monitor. The resolution was like all right. I would like it to be a little bit higher resolution, but it's okay. I mean, I can make it work. I can make it work. But we can get back to the old habits. I can put everything up on the top, and then can monitor how the stream going at the bottom, and then everything feels right. Or that's the first thing that feels right. The second thing that feels right is that problem's been bugging us for 3 nights, maybe 4 nights. Look at that. Look at that. June 17th, that's today, 6:39 in the AM. So what happened was this morning, my alarm clock sounds at like 5:45, and I usually took like another half an hour. But those half an hour is really light sleep, so it's not deep. I was able to actively crunch some stuff in my head. So I don't understand why I got so troubled by this problem. And during that time, I finally figured out how the dynamic programming works. So it works like this, right? So we have, let's consider the situation with the maximum 3 repeats. So we have, I don't know, like n uh, number of repeating one thing, right? So what we know is we can always take a 1, right? One of it at the front, so the remaining is n minus 1. So I just need to find the total number of possible ways for n minus 1, right? And then that will be everything that will start with 1, start with 1. And then I say, okay, how about how many we can have start with 2? And then we start with 2, and then the remaining is n minus 2. I just need to find the maximum we have with n minus 2. And then we go to start with 3 and n minus 3. So it turns out if we have a DP table, right, and then we start to say for each new n, we just need to add dp n minus 1, n minus 2, n minus 3. We add them together, and that's it. That's the new one. So by doing this, we can solve the single way. Simple, straightforward, nothing too complicated. Like seriously, it's very, very easy. During my implementation, I did go use some like tricks. It's like you didn't see me do 3 things added together, because every like this value is these 3 added together, right? So if that's the case, if we want to calculate the second one, and the next one is going to be 2 plus 4 plus 7. I already computed 1 plus 2 plus 4 equal to 7. So I can just use this plus 7 again minus 1. So that's why it's 2 times the n minus, in this case, we have to go 1, 2, 3, 4, right? Minus 4. And then if we have the allowed repeat is 4, then it have to be minus 5. So that's basically it, right? That's that. And I'm waiting for now to write a comment. So the DP works like this, right? Say we are, okay, there's one thing that's not good. The table shakes. And as the table shakes, the monitor shakes. So that's the one thing I do not appreciate. I feel like there got to be a solution for that. How can I reduce the amount of shaking that this table does? I mean, for one thing, we can get a better table. This is a folding picnic table that we've been using for, I don't know how many years. 4 years? Still strong. It's just the monitor shakes. That's the only thing I don't like. But I guess I just need to type lightly. Well, yeah, it's shaking right now because I'm putting my elbow on the table. All right, anyway, so this is what we say. Say we are try to find the maximum number of ways to handle, let's say, k number of repeated digits. Also, let's say the max single unit, right, of repeat is 3. Then we know the final answer must be some ways start with 1 repeat, right? Some start with 2 repeats, and some 3 repeats. This means the total number of ways for k number, right, of repeats is dp k minus 1 plus dp k minus 2 and plus dp k minus 3. So use this relation, we can compute all. We can compute the maximum number of ways for every length of repeated values, repeated digits. Yeah, that's about it. And we'll call it OM because this basically we do some computation, but it's going to be OM. Yeah, so that's that. Good problem. Stuck up for so long. I mean, in the future, I'm going to go back to this problem and look at this and be confused. Wait, what are you talking about? 15 and now we got 17. Yeah, it doesn't make any sense. But it's a good question. Very good question. Alright, so now we're going to go to today's challenge, which surprisingly is also a difficult problem. But we solved this before, so let's see, what do we have? Design a special dictionary with some words that searches the words in it by a prefix and a suffix. Implement word filter. Initializes the object with the words in the dictionary. If F returns the index of the word in the dictionary which has the prefix and the suffix. The largest of them. What do you mean the largest? Oh, index. So apple, A and E, that'll be 0. I do not remember this problem at all. Alright, so prefix suffix, the first things you think about is just we build 2 try. One try going front to back, the other try from back to front. And when we have a hit, it's just we climb through the tree and then we have a hit. But we could have multiple hits, right? We could have multiple hits. And we can like at each node we'll record the indices, right? We each node indices of 15,000. So all these indices, we go front to back, we have the indices, and then we go back to front, we have indices, and then here's the intersection and a final maximum. Okay, let's try this. How good is this, right? Everything is large and then they're on a different screen. I mean, I like it, but if the font can be like slightly smaller, I think it'll be even better. Alright. This is not bad. This is not bad at all. I mean, Yeah, I take it back. I actually like it to be bigger because if it's too small, I won't be able to see it. Okay, so we're gonna build a try, right? Build try. Words. Well, we're gonna return two things. Okay, so we're gonna return a tuple of try. Oh, let's just not do this. Oh, I think the default dict. Right? So I think it's default dict lambda self.try. Right? No, I don't think so. Hold on. Let's no, try is a lambda. Try is a lambda. No, wait, hold on. Try is a default dict. And then it'll be lambda return default dict. Yeah, I think this is correct. Right? Right, so we have a try. Yeah, I think this is correct. So that's try. And let's say left to right, L to R root. No, it's not right. It's a lambda that returns a default dict. This is a try. It's a lambda. It's a function. Right? It's a function. So I have self right to left. Okay. So we're going to build a try. We can just call self tries words. Alright, we're going to build two tries. One is from front to back, and we're going to put everything in there. For W in words, okay? For each new W, we can say left to right, node equals self dot this, right to left, node, not node, self dot right to left root, okay? Then we're gonna go through, say for actually I need indices. Alright, for letter in words, I say L to right node. So like at this node, how many? So we need to say if, let's say, pound, I'll obtain this, right? Then we'll call it set, right? And then simply say L this node this add letter. No, add word. Add what? It's gonna be a set, and I want set. We just want the index, so just I. Okay, and then as we set it up, I can say L to our node shall equal to L to our node as a default dict. Letter. Right, we go to the next one, and every time we do, we will add the indices. Right, so if you here, then we have at least this one. Yeah, that's prefix. Okay, now I'm do the other one. Supposedly should be the same. What's the length? 10. So we say this, right? So I'm just going right to left, right to left. Okay, so we built 2 tries. Right, at the end, we don't have to return anything. So we just do that, and now we build 2 big tries. So in here, we can say if it doesn't exist, minus -1. Okay, so say for letter in prefix, if letter not in. Oh, so L to R node equals so right to left, right to left. Okay. So now we're gonna go through. If it's not in to our node, right, then we return -1. That means we have a letter that's not in the prefix. Otherwise, LTR node shall equal to LTR node letter. Right, so we're going to new one and into the last one, right? So the last one letter in, and then it's the last letter, and then it will go for that. But we record is based on letter, right? If the letter comes in, then we record a color. I'm starting to talk in gibberish. So for each letter, I'll put this, and then it's like when I add this letter, I add this index. Okay? So in this case, right? Yes. So if it's the last character in, if it's the last character in, and we'll check. Ooh, I think we should always check. So L match, right match equals set and set, right? And then every time if the letter in prefix, if letter not in L2R, then we just like, yeah, we cannot handle you. Otherwise, we can. Then we should just say, what was the match the entire thing prefix? We can say this one shall equal to no node L match. What is this equal to? L match shall equal to L this node this, right? This is because we will move on to the next one. If we want the next one, then it kind of defeats the purpose. Yeah. So as one comes in, and then it will append the index so we know which one, and then it will go on to the next one. So so all the things should be in the previous node, right? If I move on, then we want to send to the next. That we don't have the data, like which one are matched. Is that right? This should be right. I'm gonna do the other one. So this should be this is suffix, right? Letter not in, right to left. Right, now we're gone, and this is gonna be our R match. Okay, so it's the same thing because we go suffix. Oh, hold on, what's the suffix? Should we go back to front? Yeah, I think we should go back to front. And then the first thing what we have is going to be, oh my god, I am so sleepy right now. If it's not in, that means we don't have it, so return -1. If it does have it, then the match, like how many have matched is the current we put in here, right? And then we move on to the next one. Now we just go through everything. So once we're done this intersection, right? So we LT this dot intersection R this node, and then we just return maximum of this. All right, let's see if this one what works. And more test cases. That's it. That's all the test cases they have. See if it works. Higher. Okay, that's definitely wrong. Try. That's the debugging session that we need. Oh, 2 left. Oh, that's the wrong button. Intersection. Interesting. I put it as a set. Maybe we should first. Wait, hold on. What was the problem again? All attributes. I have set this to this. Wait, what was wrong? It was 0. Ah, yeah, it is all 0. Because they all refer to one letter. Okay. Seems like these are fine. Intersection. The hell? Oh, oh, I see. It should be L match. Oh yeah, I don't know why. This is L match. Those are the sets. This one seems to be working. So what do? We submit it and see how it goes. Ooh. Runtime error. Max is empty. Oh, so let's say, hold on, I'm changing here. First of all, this is rest, let's say, equals this. Now, L match dot intersection R match. Alright. And say return max res if res else minus 1. This. Any test case is a good thing. Oh, tire. Where? Tire. Remove this. Oh man. That's worst. Body starts to shut down. And we haven't even finished this problem yet. Oh yeah, I have that too. Where it is? Alright. Now it should be right. What? Oh. What's the test case? Hmm. Still sleepy, but I guess we can. There's one start with F. See any? Nine. Oh. Yeah. There are a lot more. Well, I got a runtime error. Then when I test this, what do I get? I don't know. Do I have to match everything? I have to match everything. Let's see what happened. Yeah, it's probably not the best way to print this. No, I have to. So I have to just copy this. Let's find a bigger place to work with. So this is hold on. Let's just focus on one test case. Delete this one. Okay. Top level is C. Oh yeah. Prefix and suffix. That's the dictionary. Yeah, let's do it this way. Okay. So that's the dictionary all the way to here. And these are the test cases. Prefix and suffix. And I was supposed to have 9, but I returned -1. BCC. I don't have BCC. Oh. Oh. I gotta stand up. This is not working. Ugh. But why am I not catching anything? That's the weird part. Okay, now the last one should be 1. So The last one is CCBCA, right? And CABA, yeah, the last one shall be fine. I don't understand. What's the wrong? Let's simplify this. I'm just using the last one. So just one of them, right? And then it's not print here. Maybe we can print the L match. We probably print R match as well. See if we can gain any insight into this. What? Oh. Am I printing something else? What is this? So I'm going inside some weird stuff. Going too far. It's prefix. Yeah, so there's a new one, and a new one, and a new one, and the last one coming up. The last one coming up. Huh. It seems like we did one more. I mean, for one thing, I can just check. And just say if. And I think I'm going to a no that this is not. I don't know how, because the process of building it doesn't seem to allow the creation of a new node without being inside. unless the left prefix is we left prefix, so we go C, right? This will be this one. We have C, and then we have a match pound. Right, C, we have B, okay, now we have another one. So we just pick C, then we go inside because node equals node letter, so we go into the next one, and then the next one. Oh. Let's come out of this. Just want to take a closer look. The left is correct. The problem is on the right. Interesting. I don't see an issue. For each word, I'm reversing it. And in here, so suffix, I reverse it. Wait. Oh, for one thing, should be R to left. Should be R to left. There we go. Okay. Yeah, this is purely because I'm so sleepy and I forgot to change the code. And now we can go full boss on it. Come on. Show me. Ooh. We're wrong on the third one. One, two. That is interesting. A and AA. A and AA. A is a prefix. Oh, yeah. A is a suffix. 0, 1, 2, 3. 0, 1, 2, 3, 4. 5. What was the answer? Should be fine. My output is 9. Mine is wrong. How is it 9? 0, 1, 2, 3, 4, 5, 6, 7, 8. 9 is this. Didn't even work on the first set. Huh? Wait, this one feels weird. How much shall be just 5? All the way to 9. Oh. Oh, because later. Oh. Set. No, not set. So instead of doing a set, we're gonna go full on tuple. And then this is just going to be no. We can simply turn, let's say, set this. The intersection set this. Alright, let's see. What? So now I don't understand. I already put it as a as tuples. Oh, I see why. I see. The problem is they're sharing. Everyone's sharing. So what we need to do, oh my god. So instead of doing a set, okay, first of all, I need to change the code here because it's just miserable here. Okay, so instead of a set, let's do a dictionary. Okay. Oh, even better. Let's do a default dict of a set, and then it will be this letter dot add, and this is the same thing. Say default dict set, and this is this in the letter dot add. So blah blah blah, it's fine. And then L match, it has to match the letter. This has to match the letter. All right, let's try this one. "54 minutes. We're getting close to our limit, and I'm already almost dying right here. Almost have no capacity anymore, but we're still fighting. We're still fighting. I mean, if you listen to the recordings earlier, it's actually incoherent. I'm telling you, it's incoherent. Let's also have the original test case, just for fun, see if it works. Apparently it does. All right, now we have more confidence in this. Let's see if we can get this one done. Come on. Oh, you don't have to do this to me, man. Why do you do that? What did I do? I just press submit again. Oh, it's not intentional. Holy guacamole. So the word is A. I want a maximum, right? I want a maximum. So the words can be simplified. I just need to know the maximum. Right? I just need to know the maximum of each, like for each word, right? I just need to know the maximum because they say if we have multiple match, we just want a maximum. So if the original word has, yeah, we want to go with the maximum. So how about we handle those words first? How do we handle? We go through them, right? We go through them one by one, and then we have a max indices. Okay. Default dict 0. And say for I word in words. The max indices word equals I. Just a dictionary. Okay? Perfect. And now here, right, it's going to be word and index in max indices dot items. Then this will be fine, this will be fine. This will be index. This will be fine, this will be index. Everything else I think stay the same. Okay, let's try this one. Probably better work because we're at 59. Try this. For I would enumerate. I like the other test word. Not test word, test cases. I'm gonna try that one. Oh, that was the first. That was the first one, man. So I'll run 2 of these. Okay, now the ultimate challenge is this baby. This gigantic thing. Okay. Maybe this one has more promising results. Come on. Yes. 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 Oh. Oh. This is why we do this. This is why we do this. This is why we don't give up. Right? Even though I can barely keep my eyes open. I'm starting talking gibberish because the brain is just somewhere else. But we just keep pushing. Again, granted, this is not that difficult a question. It's not. Okay, it's not. But boy, is this a good feeling, right? Is this a good feeling? All right, so what do we do now? Well, I want to check the solution to see how this one was handled kind of in the past. But before we do that, we need to enumerate. Oh, this is a good one. So yeah, it's not that hard. Should we say it's hard? I mean, the solution is quite straightforward, right? 2 tries, one handling prefix and the other suffix. Now, while this is not a difficult concept to start with, the implementation could be tricky because the input can be too big, so big that it triggers TLE. Now the trick here is not to process each word, because the words can have duplicate. Since we only return the max index, right? We can deduplicate the input words and record the largest index for each word. Yeah, that's how we do it. I know we receive pretty good results. Okay, so let's take a look at this and take a look at this. These are the 2 solutions I had back in the day. What is this? Oh, this is a terrible first try. I mean, we can also go on solution. Yeah, we're timeout. So in this case, maybe we don't need a set, right? We still do. 2 tries. Here to try. Suffix wrapped words. That's the one. How did they do the set? I use another default dict. They seem to use something different. Oh, wait. Add await. Current and await. So we don't do it here. We do it before lettering word. Yeah, it makes more sense, right? No, it did add. Wait, I'm confused. For lettering word. Okay. We should add a set. And then this set, we just add this. Yeah, why do I have to do it this way? Shouldn't this just be a set? It depends on where you do it. I see. We should do it after we go through. So we should do it here at the top, because each word, it reaches this, right, initially. And then first letter, okay, so here's what I think. I will say yeah, I don't think so. First letter, right? And then go here, and then do this. So this node is from this one coming down. Same thing here. We'll say this one. Do this first. Actually, do this first. Right, coming down. And then this is just a set. And this is an add index. And then we update the match here. Okay, let's see. And after this, I'm gonna call it. Too tired. And I still haven't washed the dishes. Yeah, this one's good. So I don't have to use, depending on where you put the pound. You should put the pound after you have gone to the next one instead of at the front. Okay, that's understandable. So I need to understand this and this. And this. And I want to implement these as well. Well, something to do tomorrow. All right, I'll see you guys tomorrow. Adios.